Good morning to one and all. Yeah, I am here to teach the design of reinforced concrete structures. Myself, Dr. P. Paul Raju, Professor and Head of the Department. And this course code is 21 CE 3101, which we are going to have in 3-1 semester, third year first semester. So, firstly, I would like to bring few important things related to this course. So, don't try to cheat. If caught, consequences will be severe. Maintain silence in the class. If you need to discuss something more important than class, please go outside and discuss. So this is the typical syllabus which I am going to cover. Firstly, I would like to cover the introduction to working stress method and introduction to limit state method. So in that, concepts of limit state method, characteristics loads, characteristic strength, partial loads and metal safety factors, representative stress, strain curves, assumptions in limit state design, stress block parameters, limiting moment of resistance. Then followed by single and double reinforced beams. In that, limit state analysis and design of single reinforced beams, double reinforced beams, flanged sections, limit state design of T and L beam sections. Then in the third portion, I am going to cover shear, torsion and bond. So in that, limit state analysis and design of sections for shear and torsion, concept of bond, anchorage and development length. Even which is going to cover IS code provisions, design examples in simply supported beams. Then the next fourth module is slabs. Design of one-way slabs, two-way slabs, continuous slabs using IS coefficients. Then followed by columns, short column and long columns, uniaxially loads, uniaxially bending and biaxial bending and IS code provisions. Footings, different types of footings, design of isolated footings, square, rectangular and circular footings. Finally, I am going to cover staircases. In that, types of staircases, limit state design of stairs, spanning horizontal and dog-legged stairs, reinforcement sketches. So firstly, I would like to cover a few fundamentals about the concrete. In that, the properties of the concrete. The important properties of the concrete are, as everyone of us knows from the concrete technology subject, compressive strength, tensile strength, shear strength, bond strength, density, impermeability, durability, ductility, like that. Then among these properties, compressive strength of concrete is the most valuable and can be easily tested in laboratory. This is generally measured in concrete cubes or cylinders. Then many of the properties of concrete can be inferred from compressive strength using correlation that has been established. Then quality of concrete depends on the compressive strength. Concrete is classified under different grades depending upon its characteristic strength. What is meant by characteristic strength? Is determined on 150 mm by 150 mm cubes at 28 days successful curing. Grade of concrete is designated in terms of a number which is the characteristic strength expressed in megapascal. The number is usually preceded by the letter which refers to. Minimum grade of concrete for plain concrete is M15 as per IS 456 code book. Minimum grade of concrete for RCC is M20. Of course, if we are located nearer to seashore, that is M25. The development of strength depends upon the grade and type of cement during and environmental conditions, etc. See, these are the table. This is the table which is being given in IS 456 code book. Up to M20, we used to call them as ordinary concrete. It has denoted as M10, M15, M20. M indicates mix. Then followed by characteristic strength. M10 will have 10, 15, 15 and M20 will have 20. After M25 onwards up to M55, we used to call them as a standard concrete mix designs. Then after that, we can call them as a high strength concrete that will start from M60, 65, 70, 75, 80, so on. Then what is meant by tensile strength? The flexural and splitting tensile strength shall be obtained as per IS 516 and IS 5816 respectively. When tensile strength is to be estimated from compressive strength, the following formula may be used. This is the empirical expression, that is flexure strength can be calculated FCR equals to 0.7 root FCK Newton per mm square. Elastic deformation. Module of elasticity is primarily influenced by elastic properties of aggregate and to a lesser extent by conditions of curing and age of concrete, mixed proportions and type of cement. The modulus of elasticity is assumed by, as per code, EC equals to 5000 root FCK in Newton per mm square. Then thermal expansion, coefficient of thermal expansion depends on nature of cement, aggregate, relative humidity and size of sections. Coefficient of thermal expansion varies between 0.9 to 1.3. Creep. Increase in strain with time, time dependent component of total strain is termed as creep. Creep coefficient. Creep strain at a time t, instantaneous strain. Maximum value is called the ultimate creep coefficient designated by theta. Its value is found to vary widely in the range of 1.3 to 4.2. Effective modulus of elasticity from the code book, ECE equals to EC by 1 plus theta. There are two criteria. Deflections has been classified into two types. The first one is short term or immediate deflection. The immediate deflection occurs due to loading on concrete member, whereas long term or time dependent deflection, time dependent deformations occur during service life of structure. Then immediate deformations are elastic deformations, time dependent deformations are creep and shrinkage deflection. What is meant by creep of concrete? Time dependent increase of deformation under sustained load, factors affecting creep and shrinkage of concrete, age, applied stress level, density of level, density, cement content in concrete, water cement ratio, relative humidity and temperature. For stress in concrete less than 1/3 of the characteristic strength, the ultimate creep strain is found to be proportional to the elastic strain. The ratio of the ultimate creep strain to the elastic strain is defined as the ultimate creep coefficient or simply creep coefficient, that is theta. As per IS 456 is considered only the age of loading of the concrete structure is calculating the ultimate creep strain. Curing the concrete adequately and delaying the application of load provide long-term benefits with regards to durability and deflection. In special situations, detailed calculations may be necessary to monitor creep strain with time. Specialized literature or standard code can provide guidelines for such calculations. Shrinkage of concrete. Time-dependent strain measured in an unloaded and unstrained specimen at constant temperature. The factors responsible for creep of concrete will have influence on shrinkage of concrete also, except the load conditions. Shrinkage. Concrete shrinkage in the hardened state due to loss of moisture by evaporation. Consequent reduction in volume is termed as drying shrinkage. For design purpose, the ultimate drying shrinkage strain value of 0.0003 is specified. Temperature effects. As a consequence of seasonal variation in temperature, internal stresses are induced in structures owing to restriction in movements. In order to limit the development of temperature stresses in reinforced concrete buildings with large plant dimensions, expansion joints at appropriate locations are provided. For RC, minimum cement content is specified as 250, 290 and 360 kg per meter cube for mild, moderate and several exposures, and the water cement ratios are 0.65, 0.55 and 0.45 respectively. Now let me start some visual video which will give the elaborated idea about the fundamentals of the design reinforced concrete structures in this visualized video. So from this I could able to explain each and every parameter what we have been understood about the properties of the concrete. If you talk about the design of different types of structural elements, the first understanding is what is beam, what is column, what is slab and what is footing. Once we understand this, if you talk about the objectives of structural designing and process of designing, plain concrete and reinforced concrete, then basics properties of concrete we are going to discuss, followed by We are going to see these all parameters in terms of grade of concrete, casting strength of concrete, modulus of elasticity of concrete, creep and shrinkage, which I just before explained, and even durability. Of course, basic properties of steel and their types are also we are going to discuss in this subsequent slides. Then objectives of structural design is what? The main objective of structural design is, first thing is strength. Concrete cubes will give the strength, and of course steel will be there along with the concrete. Then if you apply the compressive load, and if you could able to apply the tension, you can see here in this video, you can see the how compression load is being applied and tension is being applied, and there is a checklist. You can select which is suitable from the IS 456. Say I have been selected so and so, which is satisfying the my strength and stiffness criteria, then I could able to choose. If you see, there is some statistics disaster management of India provided. They have, in the year of 2013 also, there is a 7-story building collapse in Thane, Maharashtra, because of not properly designed. The reason was use of substandard construction material. That was the main reason. So we have to be very careful about the strength. Stresses should not exceed the critical values. That is meant by strength. Then we have to look about the stability. The stability is the another important point. How we can ensure the stability? The building which you constructed, it should not fall. Then there is a curve, you can see in the diagram, there is a 40-meter curve. That flyover has also fall down. The reason was not properly designed, because of stability is not there. Then overturning, buckling, sliding should be prevented. This is the main objectives, and even serviceability point of view, we have to be very careful. It is a condition under which building or structure is considered useful. Ensure the satisfactory performance of structure under different types of load conditions. So these are the main objectives of the structural design. In the serviceability, you can see stiffness, deflection, impermeability, durability can be considered, and this has to be satisfied. That means the entire life period of the structure should not give any warning that this building is going to fall, and if any crack is there, the user will feel that this building is going to fall on me, and I don't know when it is going to fall on me. So that kind of feeling should not be there. That being as a designer, we have to ensure that. So at final, if you see the summary point of view, how we are ensuring strength and stability and serviceability, this is the main criteria when you go with the structural design objectives. Then reinforced concrete construction. Here you can see in the reinforced concrete construction, what are the main factors we are going to follow. Like first one is planning phase. In the planning phase, carried out by architecture and planner, plan the layout of the structure, then functional requirement, aesthetic requirements, even budgetary requirements. So these all will comes under the planning phase. Then after planning phase, we have structural analysis and design phase. Selection of most appropriate structural system to bring the architecture concept into being. That is the another important task. Then estimation of loads on structure. Then structural analysis for estimation of stresses. Then structural design of actual proportion, size, reinforcement, etc. for safety and serviceability point of view. So this is the very important phase which you talk about the reinforced concrete construction. Then another phase is, are the safety and serviceability requirements satisfied? It's a question. If it is yes, okay. If not, if it is yes, it will go to the construction phase. If not, again we have to come back to the structural analysis and design phase, and you have to revise the structural design. So it will go back to the structural enhancement design. Then there you can change the size of the member or load reduction or anything you want to increase the metal properties such as grade of the concrete, grade of the steel, or increasing the number of bars, that means percentage of the steel, like that. Then concrete and reinforced steel, how their characteristics are there, how they will play main role in the construction of one RC building. If you see, we have plain concrete is made by mixing of cement, aggregate, water, admixture. And concrete is generally prepared at the site itself, although ready mix concrete and precast concrete are also used. Then concrete compressive strength is very high, you can see in the photograph, whereas concrete tensile strength is very low, negligible compared to its compressive strength actually. But when you try to apply the load on the one simply supported beam, that beam will goes under the flexural failure. That means the failure may occur at the center, maybe vertical cracks and horizontal cracks indicates the flexural failure. Then you can see here the what is the steel bar embedded in the concrete, then it will become a reinforced steel. Then reinforced steel plus concrete will become RCC, reinforced cement concrete. So then usually manufacturing factories under controlled conditions, this steel, it can effectively take up the tension that induced due to flexural tension, direct tension, diagonal tension, environmental effect, like that. So these all points are very important if you look at the structural steel, reinforced steel. So you can see here how the load is being applied for this beam, and the cracks are happening here. The cracks are occur at the button, but because of that steel, this is getting controlled. That means the failure become ductile mode of failure under heavy loads. So steel also impart ductility to materials. So I think with that note, so I would like to stop here with the first session, and here you can see, if you want to ask me to summarize, so steel compressive strength is more than concrete. So I'll continue this class in the next session. Yeah, thank you one and all.